That's the company. They're proposing a new route due to changing winds.
Yeah, continuous climb, okay. Right, inform ATM, we accept the new route. You know, it's so simple now. We take that flexibility for granted. It's not like the old days, before fans.
What was it like then?
Well, in those days, the air routes relied heavily on ground beacons and VORs and radar coverage. What this meant was lengthening the route artificially. Instead of taking the shortest route, planes had to go through such and such a waypoint. Of course, this decreased cargo and passenger capacity, and so profitability took a beating too. Everybody was squeezed into more or less the same routes, which got more and more crowded and harder to manage. You won't believe it, but it got so bad that taking off 30 minutes behind schedule seemed perfectly normal. In fact, the situation was pretty worrisome. The way things were going, at the turn of the century, we were headed either towards the impossibility of meeting air traffic demand or towards real safety problems.
That was just the continental routes, I suppose. The dense congested zones like Europe, for example.
No, not necessarily. In areas like the Pacific, which were physically much less crowded, there were also technical limitations on air traffic. For example, sparse radar coverage and poor communications forced planes to fly within enormous safety bubbles. This led to artificial route saturation. So something had to be done. Everybody in the industry knew it. ICAO had already defined what the future systems for communication, navigation, surveillance and air traffic management should be. In fact, what they are now.
And so nowadays, you think things have changed?
You'd better believe it. The routes are shorter. This saves fuel, increases the payload capacity, sharpens the competitive edge. GPS makes precision navigation possible. I know exactly where I am. Satellite communication and data link allow permanent contact with air traffic control. They know my exact position and my heading wherever I am, all the time. The safety bubble is smaller. That means less saturation, better flight plan management, and of course, all this leads to better regulation and less waiting.
How did it all start?
I was there right from the start. The airline I worked for had foresight. We had our first Fans A equipped Airbus fleet by 2000. Version B, more or less what we're flying now, was ready 3 years later.
I guess that made a difference.
You bet it did. Fans A improved communication and ATC in deserted zones like the South Pacific first. From there, its use spread very quickly. The thing is, for high-density zones, the changes had to be more radical. With traffic levels moving so quickly towards saturation, following ICAO's ATM plan became urgent. The competition offered fans installations too, but their equipment was not up to ICAO's specs, and it was introduced at a time when ground infrastructures and procedures weren't really ready yet. It was a stopgap solution. Airbus was the only company to build the concept into the planes from the beginning.
How big a change was that? I mean, in terms of the aircraft.
Well, for Airbus, it wasn't just a facelift or simply adapting to circumstances. It was the logical progression of their overall design philosophy. You see, the aircraft are designed with a high onboard computation potential and inherent capabilities for digital data exchange with ground systems. They incorporated GPS navigation early on, as well as satellite communication. They used DGPS for precision approaches in the late 90s. Of course, ergonomics had always been a consideration too. They put a lot of attention into the design of the human-machine interface. And consulting the users from the start was standard practice, whether it was the flight crew or the airlines. All of this enabled Airbus to provide a fully integrated system by 2000 as standard equipment.
What was the advantage of that?
Lots of advantages. First of all, hardware and software commonality for the complete line of Airbus fly-by-wire product, with all the advantages that this gives in terms of training, maintenance, cost and crew efficiency. Then there's the ergonomic integration with a dedicated display rather than overloading an existing display. Look, we're just receiving an ATM message. Now, as it's displayed on DCDU, you see I still have MCDU information. No need to switch and no risk of missing a message. Data link. Now that was a real breakthrough. You can't imagine the speed and the accents with which I heard some controllers speak English.
Some pilots too.
Confirm, sir, you are talking about turbulence or some fire?
No. Turbulence. We have CHOP report here at 310. We want to know how long it goes.
What is the meaning of CHOP?
CHOP. Turbulence.
Ah, okay.
But no risk of confusion now. All these choices resulted from discussions with airlines and flight crews. You see, technically, an open architecture made moving from fans A to fans B very easy as soon as it was available. All you had to do was install the software and you were ready to fly. In practical terms, it meant that Airbus had offered from the outset a fans B solution that was also usable seamlessly in a fans A environment. Of course, if you'd installed a stopgap solution, well, you were at a dead end.
Okay, but was it profitable?
Profitability immediately took a sharp upswing with fans A on routes like Los Angeles, Hong Kong. On continental routes with lots of beacons, like Singapore, Paris, for example, our investment paid for itself in 3 years. As for the fans B upgrade, it took less than 2 months to pay for itself. Because, you see, fans B shortened the route by more than 350 nautical miles.
What about the transition?
Well, the transition didn't take place overnight. It's just that Airbus had the most flexible aircraft. They were ready to adapt to a wider range of technical and operational contexts.
It sounds like it was the obvious solution. Why wasn't it applied earlier?
Well, it really was a big jump. I don't mean a technological one. The techniques employed by fans were available. GPS, digital satellite communications, and so on. But the real challenge was bringing them together so they could be useful for air traffic. This meant evolving from a system based on heavy ground infrastructure. It didn't just concern the plane builders. It also involved management authorities and national governments who owned these ground infrastructures. You know, such a big change was not an easy decision to make, despite all the benefits. But the advantages went beyond just responding to traffic growth. Fans B brought enormous flexibility to flight path management. It enabled us to move from air traffic control to real air traffic management. And Airbus played a key role in this development.
So, it's all history now.
Right. At any rate, the economic advantages were obvious, and technically, there was no getting around such a change. There was no way traffic could keep growing the way it was, and that we could still guarantee safety using the conventional techniques of the day. You know, sometimes I wonder where we'd be now if Airbus hadn't taken a long-term view and planned ahead